Hello and welcome to the DBForge Studio for MySQL tutorial. DBForge Studio for MySQL offers some powerful features to help you get more information about database objects. With DBForge Studio for MySQL, you can view database table properties, view table or view dependencies, generate database diagrams, generate SQL scripts for objects, and create database documents. In this video, we will use DBForge Studio to reverse engineer a MySQL database. We are going to use a freely available MySQL sample database called Sakila for the demo. The Sakila sample database represents a fictitious DVD rental store. It has more than a dozen tables, about half dozen views, and 3 stored procedures. We are running this database in an Amazon RDS MySQL instance. To start off, let's right-click on the Tables node and choose Show Details from the pop-up menu. This opens up a grid in the Detailed pane where we can see more information about each table. From here, we can see the storage type, partition status, row format, or the number of rows for each table. If we scroll right, we can see other information like character set, collation setting, and the date and time the tables were created or last modified. This is good, but it doesn't show us how the tables are related to each other. Sometimes we need to drop or modify a table or view but can't do so because other tables or views are depending on it. To see if a table or view is used by another table or view, you can expand the Table or Views node from the navigation pane and then expand the Depends On or the Used By folder. The Depends On folder shows the objects this table or view is referencing. The Used By folder shows if any object is referencing this table or view. In this example, we are looking at the film actor table. As you can see, it's a foreign key table and depends on 2 primary key tables. In the Used By folder, we can see there are 3 views which references this table. It's a great way to see how tables and views are related to each other, but not very easy if we have to look through hundreds or even dozens of tables or views. A better approach would be creating a database diagram. A database diagram is basically an entity relationship diagram that shows table relationships in a graphical manner. To create a database diagram, we choose Database and then Database Diagram from the top menu. This opens up a canvas in the Detailed pane. Next, from the navigation pane, we select all the tables in the database and then drag them onto the canvas. DBForge Studio for MySQL now finds all the table relationships automatically and arranges them in a nice ER diagram. Let's zoom in on the diagram. We are now seeing it at 100% scale. As you can see, the diagram shows all the tables and their fields, field types, and foreign keys. We can also click on the arrows to show the table constraints and any indexes used. This is really useful. We can save the database diagram with a .dbd extension. We can also create database diagrams for views or even stored procedures or functions, but the diagrams wouldn't show what tables or views they are using. If we want to go one step further, we can choose to generate SQL scripts for tables, views, procedures, or functions. This can be then saved in version control systems like Git. To see how it works in DBForge Studio for MySQL, we can right-click on a database object, choose Generate Script as from the pop-up menu, select Create, and then select to New SQL window. Here, we have generated a Create Procedure script for the film in stock stored procedure. For most database tools, this is where the reverse engineering features would end. DBForge Studio for MySQL goes one step further and lets you create a full-blown database document. This database document brings everything we have seen so far in one place. To create a database document, we select Tools and then New Documentation from the top menu. This opens a dialog box where we can choose the database connection we want to work with. Once we choose the connection, a wizard opens up. The left pane of the wizard lists all the databases and users in the MySQL instance. From here, we can choose the databases and the users we want to include in this document. The first part of the database document is the cover page. From the wizard's template, we can include a logo, add a header, subtitle, and short description of the document, fill in the author, copyright fields, and choose the Created on Date fields format. Next, we select the database we want to document. Here, we are choosing the Sakila database. Note how the document template changes for each type of object we select from the navigation pane. For each object, we can include or exclude particular types of information. Once we are happy, we can decide to save our database document in dbForge native format or export it. To export, we click on the Generate button. As you can see, dbForge Studio for MySQL offers three options for exporting: HTML document, PDF document, or Markdown document. We want to export to PDF, so we choose this option and then change the export path to C temp dbdoc. We also select the option to open the document once it's generated. Our database document is now created and opened in a PDF reader. If we scroll down, we can see all the object definitions, field types, dependencies, and SQL scripts. This document now becomes a good reference for future purposes. This completes our tour of database reverse engineering features in dbForge Studio for MySQL. We hope you found it useful. With 160 products, Devert is one of the top database companies in the world today. On average, Devert products are downloaded 37,000 times a month. Nearly 60% of the Fortune 100 companies use Devert database tools. To know more about these products, visit the website.